Welcome back, everybody. This is going to be part 1 of 3 in my lecture series on compositions of functions. Let's get started. We're going to start by learning how to find the domain of composite functions without the use of their graph. But what do I mean by a composite function? Each of the 4 here could be represented as a composite function, and we're going to learn how to do that in the third part of this lecture series. For now, you can sort of think about them as combinations of different types of functions. For example, part B looks like a polynomial inside of a radical, right? So it's a composition of a polynomial with a radical. Same thing over here. It looks like a polynomial with a fraction, right? That's what we call a rational function. That would be a composition of simpler functions. To start, in part A, essentially the question we want to ask here, rather than find the domain, is what x values are allowed? What x values are allowed? Oh, and my head is in the way. What x values are allowed? Well, in the first one, I can plug anything in, so it's kind of misleading. In general, polynomials have a domain of all real numbers, because I can plug in any x value without an issue. But it becomes a little bit more apparent why this is an important question to ask in problem B. Here, I've got a radical. And we know from previous videos that I can't just plug any kind of number into a radical. I can only plug in non-negative numbers. So, whatever is under this radical here, in this case it's x minus 3, whatever that number happens to be, we know it's got to be greater than or equal to 0 for the output to be a real number. This gives me an inequality to solve for x. I can add the 3 to both sides, and I'm left over with x is greater than or equal to 3. These are the x values that allow us to get an output. So it's part of our domain. Here the domain would be from 3, including it, onward. That would be the domain. Let's try a couple of trickier ones. In part C, I also have an issue that could come up. Notice that I've got x's in the denominator of this function. We know from the past videos and our past math classes that you cannot divide by 0. So whatever this denominator happens to be, in this case it's x squared plus x minus 12, we know that it can't be 0. So we need to find the x values that make sure this is not 0. I can solve this by factoring into x plus 4 and x minus 3 not equal to 0. And using my 0 or not 0 product property, I know that x plus 4 isn't 0, or x minus 3 can't be 0. So x cannot be negative 4, and x cannot be 3. If I were to write that in interval notation, all the numbers to the left of negative 4 are fine. All the numbers between negative 4 and 3 are fine. And all numbers to the right of 3 are fine. And now I just need to union them together. And that would be the domain. Go ahead and pause the video here to see if you can do part D on your own. The answer that I found was 10 to infinity, not including either. I saw 2 things going on here. First of all, I have a radical, so I know the thing under the radical has to be greater than or equal to 0. but also that radical was in the denominator, so it can't be equal to 0. My x values have to satisfy all conditions, not just one of them. So 7x minus 70 has to be strictly greater than 0, the thing under the radical slash thing in the denominator. Solving that inequality for x, I got x must be greater than 10, and in the red box, I have that written in interval notation. Here's a challenging problem for you. Go ahead and pause the video here to see if you can find the domain of y on your own. The answer that I found was all real numbers except for 0 and 3. Here's how I got that answer. First things first, I noticed that I have a denominator, and that can't equal 0. So whatever 3 over x minus 1 is, I know it can't be 0. Solving that equation for x by adding the 1 over, and then multiplying both sides by x, gave me that x can't be 3. But this guy has a denominator of its own, and I know I can't divide by 0 there either. So its denominator, which is just x, can't be 0. So everything to the left of 0, between 0 and 3, and to the right of 3 are just fine. In this video, we looked at how to find the domain of composite functions. In the next video, we're going to look at some more function notation that pertains to these composite functions. Catch y'all in the next one.